All right, hi guys, very good evening everyone. Very good evening everyone. Welcome to the session. Welcome to Om Institute and welcome to the next session on the PYQ practice. Okay, so after control system, I took up the session on signal and system. Okay, the previous session we have taken 1 mark question, and this session we are going to take 2 mark questions. Like previous session, I took all 1 mark question ECE. This also we are going to take all the 1 mark, all the 2 mark question. Okay, for both EC and EE. For both EC and EE. All right, dear. Very good evening. Come on, everybody, quickly keep on joining the session. Okay. Yeah. So let's get started, dear. Okay. By the time others will join. Here it is, the first question. Okay. Here it is, the first question for us. So there is a system given below. Now you see, if you have seen if you have followed the previous session, there was a very similar question. I mean, options were slightly different, but the system was given as same. Okay, there was the very same question in GATE 2023. That was in ECE. This was EE, and that was 1 mark actually. Same question was there, yt equal to x e power t, and what you had to check was causality and time invariant. So this was non-causal, okay, and it was time variant. Here they are asking about causality and linearity. Causality and linearity. So come on, you can again participate. Okay, you can again participate and check your answers. Come on, keep commenting the answer. Okay. Just a second, slide video settings, I'll have to adjust, I think. Okay, yeah. Good evening, Nutan. Good evening, EE. Okay. So yeah, what it is, now see, y depending on x power fun. See, any separate function of time or any changes in time argument doesn't depend on linearity. Y depends on a x power 1 function. Okay, y equal to mx relation. Yes, so this is going to be linear. Okay, it is non-causal as I explained you in the previous session. Why? Because once again I'll tell you, suppose you wanted to calculate y0, it becomes x of e power 0. E power 0 is 1. So if you are calculating output at 0, the value of input required is at t equal to 1, which becomes future. Okay, so future means non-causal. So it is linear but non-causal. Answer is C. Answer is C. Okay. Yes, correct answer. C. So both correct, EE correct. Yes, the answer is C. Yeah. Okay. Next question. All right. GATE 22 EC 2 marks MSQ question. Okay. What is given in the question? The output of 4 systems S1, S2, S3, S4 corresponding to the input signal sin t. Okay. For all time t are shown in the figure. Based on the given information, which of the 4 system is or are definitely not LTI? Definitely not LTI. Okay, and time invariant. I mean, LTI means linear and time invariant. Which of them is definitely not LTI? That is what you have to comment. Now see here. For the first system, if you apply sin t, you get sin of minus t. But dear, sin of minus t is also equal to, okay, I can write down sin of minus t also equal to minus sin t. Now, so in the case number 1, there are 2 possibilities. Okay, if the input is xt, okay, yt, okay, if you take yt equal to x of minus t, okay, or there may be second possibility, okay, yt is equal to minus of xt. We don't know what it is. Okay, we don't know what it is. Okay. Okay, sin minus t is minus sin t. So it could be any of this case. Okay, if yt is minus xt, this one is LTI. Okay, but in case of time folding, any changes in time argument, the system will be linear but not time invariant. It will be time variant. Okay, time variant. It will be still Okay. Hello, hello, hello. Yeah, guys. So now Y should be there. See, this one is LTI. Okay, but yeah. So in between Y's went. Okay. Okay, I'll update you about that, Chena. Okay, guys. So now audio should be there. I've. Okay. So this is what it is. Okay. Right, this is what I was explaining you. Okay, so hope the explanation was clear. What I told you in third case, time scaling or time folding. Anyways, the system will be time variant. Okay, fourth case, x square. There is no change in time argument. It is time invariant, but it is non-linear. So third and fourth are definitely non-LTI. Okay, first may or may not be LTI. Acha, one more way for this question. Okay, one more way for this question. Okay, an alternate way. Okay, if the system is LTI, okay, if the system is LTI, for any sine omega t, output is how much? For any sine omega t, the output is the same sinusoidal, I mean with the sinusoidal with the same frequency. There may be some phase shift and there may be some amplitude change. Okay, but the output is sinusoidal of the same frequency. Okay, so this also tells you that this cannot be LTI. Now sine square t, what is sine square t? Sine square t can be written as 1 minus cos 2t by 2. So here also frequency 2, here also frequency 2. Okay, so definitely these two are non-LTI. Definitely these two are non-LTI. By that also I can say that, okay, you know, C and D is the correct answer. Okay, because for any sinusoidal input, the output has to be sinusoidal for the same frequency. That also you can say, right? Yeah, you can check by t minus t naught shifting, okay, doubly, but there are simple straightforward, you know, you watch any of my other sessions on time invariance, you will get it. There's straightforward conclusions where you can easily say, okay, any separate function of time, any changes in time argument, like previous question doubly, okay, changes in time argument, normally you write xt, but if there is any change in time argument inside, okay, e power t, 2t, okay, or what I say, t cube, anything, any thing, or any separate function of time outside. Okay, like here if you multiply, that also will make the system time variant. Okay, so those are easy analysis. Okay, next question, yes. Gate 24 doubly 2 marks question. Okay, gate 24 doubly 2 marks question. Have a look into it. The input xt and output yt of a system are given by yt equal to e power minus t integral minus infinity to t e power x tau d tau. Again, they are asking about linearity, okay, or time invariance. This is MCQ only. See dear, a very simple way of solving this question. Integral is with respect to tau. Okay, integral is with respect to tau. So any term of t inside outside, to send this to e power minus t inside. If you send e power minus t inside and then combine the exponents e power minus t minus tau. Okay, so that e power plus tau is obtained. X tau d tau. X tau d tau. Now is it not the convolution formula? You can call it as the convolution. You can call it as the convolution between what? Okay, the convolution, and also if you want you can, you know, the limit okay, correct. Okay, so you can call it as what? A convolution between xt and some signal e power minus t, some signal e power minus t, right? So this is the representation of a convolution formula. Integral x tau ht minus tau, integral x tau ht minus tau, convolution. Now since this is convolution integral, okay, convolution is applicable only for LTI. Okay, system has to be compulsorily linear as well as time invariant. Then only it can be solved with the help of convolution. So it is definitely B. Convolution only for LTI. Convolution only for LTI. If any of the thing changes, linearity or time invariance, convolution formula doesn't hold. That is why it is B. That is why the answer has to be B. Okay, yeah, correct. Right, correct double E, correct Sumukha, right? Okay. Next question. If the energy, so see, this is very simple for 2 marks actually, gate 24 double E 2 marks, very simple. If the energy of the signal xt is E, okay, then the energy of the signal 2x 2t minus 1 is how much? Now, amplitude scaling, if a signal multiplied by constant, energy is multiplied by square of that value, because energy is proportional to square of the amplitude. Then time scaling, okay, time scaling, what is happening is x2t means the signal is compressed, If it is compressed in time domain, if its duration is compressed, energy will also be compressed. Okay. Right. Time shifting never changes the energy. So if you wanted the law, I will say like this. Okay. Kxt energy k square. Okay. If x of at you wanted, x of at energy will be E by A or E by modulus A. Time folding will not affect. And xt plus minus t naught, time shifting will not change the energy. That is why total answer here is 2E. So they have given answer is CE. What should be C? C is equal to 2. That's it. Simple one. Yes, Sumuka, double E, correct answer. The answer is simply equal to 2. The answer is simply equal to 2. Next question. The continuous time unit impulse signal is applied as an input to a continuous time linear time invariant system S. Gate 25, current year, double E 2 marks question. The output is observed to be a continuous time unit step signal UT. Which of the following statement is true? Now see, continuous time unit impulse is applied as an input to continuous time linear time invariant system. So what is applied as input? Okay, unit impulse is applied as input. Okay, whenever unit impulse is applied as input, output of the system is known as the impulse response. Correct na? Output of the system is impulse response. That is the definition of impulse response. Now they have given the output is observed to be continuous time unit step signal. That means the impulse response of the signal is UT. The impulse response of the system is UT. That is the information. That concept, small concept, that is what you have to pick up actually. Correct, na? That small concept, that is what you have to pick up. Okay, the impulse response is UT. Which of the following statement is true? Every bounded input results in a bounded. Now, bounded input, bounded output is related to BIBO stability, na? Is the system stable? Now, see here. HT. Is this absolutely integrable? Okay, is this absolutely integrable? I will show the calculation. I'll keep solving here only. Okay, integral minus infinite to infinite HT dt, modulus HT dt. But what is HT is UT. Now, UT is equal to 1. Okay, the magnitude of 1 is 1 from 0 to infinity. Okay, 1 dt. But what is the integral? 1 dt is t. Limit goes to infinity. So, the answer is infinity. That means the impulse response is not absolutely integrable. Okay, this impulse response, as I have shown you in the calculation, is not absolutely integrable. Dear, if this is not absolutely integrable, the system is unstable. The system is what? The system is unstable. Okay, so the given system is unstable. I'll highlight here as well. Now, what is the meaning of stable system? If a system is BIBO stable, then every bounded input produces bounded output. What is unstable system? Okay, unstable system means there will be some bounded input, not necessarily for every bounded input, but there may be, okay, at least 1 or 2 bounded inputs which will produce unbounded or infinite output. Okay, so now let's read the option. Okay, every bounded input results in bounded output signal, wrong. Then the system should be stable. It is possible to find a bounded input signal which when applied to S results in unbounded. Finish. MCQ question, only one answer correct. Answer is B. Yes, Sumuka, correct answer B. Very good. Okay. 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 So now if I read C, on applying any input to S, output is always bounded. This is again, stability definition. D, on applying any input, output is unbounded. No. Not for every input it is unbounded. Okay. Okay. So B is the correct answer as I already told you. Next one. Consider the discrete time systems T1 and T2 defined as follows. Okay. Now in T1 X, what you are doing, if the input applied is X, output produced by T1 system is T1 of X given by summation X0 to Xn. Summation X0 to Xn. Okay, what I will do for simplicity, the options are asking about stability. And as I just told you, a system is stable if bounded input produces bounded output. Okay, let's assume a very simple case. Let's say Xn equal to 1 for all n, for any value of time. It is not necessarily constant, but for every value of time, input should be bounded. Okay, for simplicity, just to explain you, I have taken a simple value. What is that simple value? 1. So, what is the output for the first system here? Suppose I call the output as y1n, that t1x I am calling it as y1n. What is the output of the first system? 1 plus 1 plus 1 plus 1 plus 1. How many times? From 0 to n. Okay, so this will be 1 plus 1 plus 1, n plus 1 times. Because I start from 0, go up to n plus 1. Now, if the output is n plus 1, whenever output depends on n, see, you have applied an input which is finite. Okay. 1, or you can take any finite value actually, right? That's what I am telling. Okay, so for all values of n, I have taken an input which is always finite. Okay, output should also be finite for every value of n, but output depends on n. Output is a function of n, and time is not in control. Your control is input. You can apply a bounded input. That's what you can do. Okay, but output depends on input. Time you cannot control. Time keeps on changing, increasing. That you cannot stop. Okay, so for n tending to infinity, okay, or I will put like this. Okay, as time grows, and time will keep growing, time never stops, y1n would tend to, this y1n would tend to infinity. Okay, meaning that unstable. The first one cannot be stable. The first one cannot be stable. Right? The first one cannot be stable. Sumukha says answer as D. Okay, good one. Now second one, same assumption if I put to the second one, what is the y2n? Okay, I'll write here y2n. Keep looking here. What is y2n? x0. Again assuming 1, then 1 by 2. Then next will be automatically 1 by 4. 1 upon 2 power n pattern is coming. A GP. Okay, a GP with n plus 1 terms. Okay, so first term 1. GP formula. First term 1 minus common ratio. Common ratio is how much? Half multiplied every term. Common ratio raised to the power number of terms divided by 1 minus common ratio. Common ratio is again half. So 1 minus half is half. 1 upon half I will write 2 into 1 minus of half power n plus 1. Okay, now multiply 2 inside. So 2 minus, and here 1 half will cancel. 2 minus half power n. 2 minus of half power n. Okay, 2 minus of half power n. That is the output y2n. Now you see here, I'll continue here. What is the output y2n is 2 minus of half power n. Correct? 2 minus of half power n. Now, even if time grows, as n tends to infinity, then also y2n will be 2 minus how much? Now, this is 2 minus 1 upon 2 power n. N infinity, so this denominator will be infinity. Okay, the answer will converge to 2. That is finite. Okay, this is bounded output. Okay, so the second one is stable. Okay, T2 is stable. Okay, D is the correct answer. Sai Vikas correct. Samukha correct. D is the correct answer. Right? So see, this one is on stability calculation. Previous one was also a good question. That is gate 25, but that is more of conceptual nature. Okay, more of conceptual. The words and definitions have to be clear for the previous question. Okay, double E. This one was also double E. Okay. Gate 23, double E 2 marks question. Okay, next question, double E 2 marks question. Okay, Ashrita. Yeah. The period of the discrete time signal xn described by the equation. Okay, what is the simple question? Okay, anyways, the DC term will not affect the period. Na? The signal will still be periodic. Okay, now for this one, what is 2 pi by omega? Okay, because discrete time signal is periodic if 2 pi by omega is rational. Otherwise, it may not be periodic. Okay, 2 pi upon 15 pi by 8. Okay, the omega is 15 pi by 8. So, pi cancelled. This is 2, 8, 16 by 15. But the period cannot be. In a discrete time domain, period has to be integer. Period cannot be 16 by 15. Okay, so what is the first period n1? Okay, what is the first period n1? It is any multiple of 16 by 15 so that you get an integer answer. The idea is if a signal repeats after 16 by 15, it will repeat after twice of 16 by 15, it will repeat after thrice of 16 by 15, it will keep repeating. Na? So it will repeat at every multiple of 16 by 15. If you choose K15, then denominator cancel and the first signal time period will be 16. It is periodic with period 16. But yes, if 2 pi by omega was irrational, here it is rational, ratio of two integers. If it was irrational, then the signal is aperiodic. Discrete time sinusoids are not always periodic. That you have to be clear. Okay, that you have to be clear anyways. Now, second one. For the second one, I will solve here. What is 2 pi by omega? Okay, it is 2 pi by omega. Omega is pi by 3. Okay, here it is directly equal to integer. Okay, it is integer. So, it is integer, then no need to take any multiple. The time period is 6. Okay, now when two signals are added or subtracted, the time period is LCM. Okay, Acha, if it was continuous, then the different rule will come. Okay, addition of two continuous time periodic signals again may or may not be periodic. The ratio of time periods must be rational. But in discrete time domain, Okay, in discrete time domain, the addition of two periodic signal is always periodic because ratio of time periods automatically integer. Why? Because every time period is integer, integer upon integer is rational number only. So LCM of 16 and 6. Okay, and LCM of 16 and 6 is 48. That is what you can mark your answer. Or it's an NAT question, you can fill up your answer, 48. Okay. Yes, Sai Vikas, Sumuka, correct answer. The answer is 48. That's absolutely correct. Okay, fine. Okay, anyways, next question. The radian frequency values for which the discrete time sinusoidal signal xn equal to a cos omega n plus pi by 3 has a period of 40. GATE 2024 EC 2 marks question. Okay, EC 2 marks and MSQ question. It's not mentioned here. The previous one was an NAT question, double E. That was 2023 to 2024 EC. Again on discrete time sinusoid. Okay, for what frequency the signal xn equal to a cos omega n plus pi by 3 has a period of 40. Okay, now see, option by option I'll go. Okay, option number A. Okay, what is 2 pi by omega? 2 pi upon 0.15 pi, pi cancel. Okay, I can write it as how much? 200 by 15 or cancel 5. Cancel 5, 40 by 3. Is it rational? Yes, it is rational. Okay, so what is the time period then? The time period will be 40 by 3 into third multiple you can take. So time period has to be integer. Okay, time period. Yes. So the first signal can definitely have the period of 40. The first one can have the period of 40. In fact, fundamental period only is 40. Okay, option number B. Okay, 2 pi by omega is 2 pi upon 0.45 pi, pi cancel 200 by 45 and if I cancel with 5, 40 by 9. Okay, so what can be the time period? Okay, any multiple of 40 by 9. So I can take the ninth multiple. So this also has the fundamental period of 40. Correct? Okay. Option number C. Okay. 2 pi by omega. 2 pi by 0.3 pi. Pi cancel and this is 20 by 3. Okay, so what is the period? Okay, any multiple of 20 by 3. So if I take third multiple, period is 40. Okay, period is 40. Period is 20, sorry. They are asking for which frequency the period is 40. Let me tell you, dear. This n that I have calculated is the fundamental period. Okay, they have not specified fundamental period. They have specified period. If this is the fundamental period, what is going to be the period of the signal? The period could be fundamental period, 40 also, 60 also, 80 also, any multiple of it. Because period is the value of time after which repetition occurs. So if the signal repeats after 20, it will repeat after 40, 60, 80 automatically. Fundamental period is that minimum value of time after which repetition occurs. Okay, that is the difference here. That is the difference. Okay, so C also is to be taken as the answer. Okay, C also has to be taken as answer. 40 comes here also, here also, here also. Now D answer is left. Then I will tick mark all other answers. Okay, D answer. 2 pi by omega. Omega is, where is that? 0.225. Pi. Pi cancel. I'll write it as 2000 by 225 or 25 if I wanted to cancel. This will be divided by 9. 25, 8, 80. Now 80 by 9. So what is the fundamental period? Any multiple of 80 by 9 and the minimum multiple you can take 9. So that denominator cancels. It is 80. If the fundamental period is 80, okay, the next possible period could be 160 or 240, but it can never be 40. Okay, in this case, period cannot be 40. So D definitely not correct. What are the correct answer? B correct, A correct, C correct. B correct, A correct, C correct. Okay. ABC, Sai Vikas now correct. Sumuka, you also first gave ABD. No, ABC. ABC is the correct answer. Okay. If the fundamental period is 80, so then the period will be multiples of 80. Now it cannot be 40. Right. Okay, no problem if you do mistake, but keep learning. Okay. Every question has something to teach you. That is the reason we are taking such sessions. Okay. Let the continuous time signals x1 and x2, GATE 25 2 mark question, okay, are given. Consider the convolution yt equal to x1t convolution x2t. See what is required in this question. Then integral yt dt. Okay, integral yt dt. Okay, area of yt. Area in case of convolution. Yt is what? Convolution of x1 and x2. Area of yt is area of x1t multiplied by the area of x2t. This is actually the definition. This is actually the definition. Whenever two signals are convoluted, their area is multiplied. That is the property to be applied. Now, what is x1 and x2? Okay, what is there? I'll draw here. Okay, I will draw here. The definitions are given. I will draw both of them. See what is given here. x1t equal to 1. x1t equal to 1 for t belonging to 0 to 1. Okay, and then okay, t belonging to 0 to 1. Okay, up to here it is constant 1. Then for t equal to 1 to 2, it is a 2 minus t. It is a line with negative slope. Okay, 2 minus 1 will be 1. It starts from here only. T equal to 1, 2 minus 1 is 1. Then there is a line of decreasing slope. Negative slope means decreasing line, I mean. Okay, so a trapezium shape is obtained. x2t, for t belonging to 0 to 1, x2t is t. Y equal to x. Line passing through origin, slope 1. Positive slope means increasing line. Then again 2 minus t. Then similar line. Again at t equal to 1, value will be 1. Okay, and then it decreases. These are the graphs. Any confusion, you can let me know anyways. Nana Sumuka. No. They are asking which of the frequency will have the period 40. That's what I'm telling. In D, what happens? In D, the fundamental period is 80. So what is the period of this signal? If the omega was this one, the period of the signal will be in multiples of 80. Okay, will be in the multiples of 80. You have to check when the period is 40. Okay, that is what. Okay, you are taking it reverse way. Correct? Yeah. So what is the final answer then? Yes, GATE exam schedule is released. ECE and EE on the second weekend. ECE and EE on the second weekend. Okay. So area of x1t into area of x2t. What is the area of x1t? Okay. So I'll calculate this area. Area of trapezium. Okay. Half. Distance between parallel sides is 1. And the sum of the parallel side, this much is 1, this much is 2. Trapezium area multiplied by second one is triangle area. Half into base into height. Okay, so this is how much? 3 by 2, 1.5, and this is 1 only. So net answer 1.5. Okay, option number A. Option number A. Option number A is the correct answer. Okay, next one. Let x1t equal to u of t plus 1.5 minus ut minus 1.5. Now see guys, I will give you this one as homework because it's a similar pattern question. Okay, again two signals are given, x1 and x2. Okay, x1 is defined. Okay, subtraction of two step signals will give you what? Subtraction of two step signals of equal amplitude. Rectangle from minus 1.5 to 1.5. x2t is shown. Same, yt is x1t convolution x2t. What is integral yt dt? Area under yt. Same question. Okay, data different but same question. Okay. Right. So that I'll give you as homework. Please do, and later on I may mention your answer in the comment box. Okay. Next question. For the unit step signal un, a discrete time LTI system produces an output signal 2 del n plus 1 plus del n plus del n minus 1. Let yn be the output of the system for the input half power n un. What is the value of y0? Gate 21 EC 2 marks. Now let me tell you, for this question, commonly you might find the answers or options, you might find the solutions with respect to Z transforms, but not necessary. I'll tell you a simple method without using Z transform only. What is given to you, dear? For the unit step input, the discrete time system produces this output. Okay, what is this output? This is the output due to unit step input. Output due to unit step input is known as what? Output due to unit step input is known as step response. So what is given? Step response, I'll call it as Sn. Okay, is 2 del n plus 1 plus del n plus delta n minus 1. If this is Sn, what is Sn minus 1? Why I am writing Sn minus 1? Because without applying Z transform, you can write down this Hn. Because even if you apply the Z transform, you will require the impulse response of the system. Okay, in time domain, the impulse response is given by Sn minus 1, subtraction of these two step responses. Okay, so what is Sn minus 1? Okay, if you replace right side n by n minus 1, this is 2 del n. This is going to be delta n minus 1. This will be further delta n minus 2. Now, when you subtract these two, what will you get? Okay, twice of delta n plus 1 delta n minus twice delta n, so minus delta n minus 1, delta n minus 1 cancel, then minus of delta n minus 2. Okay, this is the impulse response of the system obtained. This is the impulse response. Now, what is going to be the answer here? Okay, so you have 2, okay, you have minus 1, you have minus 1. Okay, these are the impulses. This is the impulse at origin. I can write it in the sequence format, correct? Impulse at origin, okay, the value is minus 1, origin marked by the arrow. Next impulse is at delta n minus 2, not n minus 1, n minus 2, okay. So, 0 has to be taken here, 0, and then next value minus 1, correct? That is delta n minus 2. And this is going to be 2 delta n plus 1. So, 1 left shifted, okay. This is the impulse response, 2 minus 1, 0 and 1, okay. 2 minus 1, 0 and minus 1. Okay, now let yn be the output due to this input. So, now further what is the input? Now further what is the input to be applied? Half power n un. Okay, half power n un. So, what is the output? Output is simply input convolution with the impulse response. Then that sequence pattern is not required actually. Okay, I'll write down the input as half power n un, which is given convolution with Hn, where Hn contains some impulses, that is 2 delta n plus 1 minus delta n minus 2. Okay, so yn in general is also obtained because any signal convolution with impulse, apply the property xn convolution delta n is xn. Any signal convolution with impulse, the same signal is replicated. So half power n un convoluted with, I'll write down 2 here, convoluted with delta n, you will get the same thing. Okay. If it is convoluted with delta n, same thing. Delta n plus 1, time shifting you apply here also. Un plus 1, half power n plus 1, u of n plus 1. Next, minus xn convolution del n is xn. Is xn only, half power n un. Minus xn convolution delta n minus 2, half power n minus 2. U of n minus 2, time shifting applied to the input as well. Okay, now the question is only y0. What is y0? N equal to 0 if you put, okay, twice half power 1, unit step will be 1, argument is positive, minus of half power 0, okay, unit step will be 1, minus, now see here, half power minus 2, but this unit step un minus 2 starts for n greater than equal to 2, right? Right shifted unit step. So if you are calculating the value at origin, this unit step is not started, that will be 0. Okay, so the answer is twice of half 1 minus half power 0 again 1, 1 minus 1, 0 is the answer. 1 minus 1, 0 is the answer. Let me see anybody. No, it's not 1 or minus 1. Sai Vikas or Shanmukha says minus 1. Good evening, Chinmoy. Okay, the answer is 0 actually, correct? The answer is 0. Next question. Okay. The exponential Fourier series representation of a continuous time periodic signal xt is defined as, okay, xt is equal to, it has to be of course small xt, summation minus infinite to infinite ak e power jk omega naught t. Omega naught is the fundamental frequency, okay, and the coefficients of the series are ak. Okay, the ak here are the Fourier series, exponential Fourier series coefficients. Okay, the following information is given about xt and ak. The following information is given about the xt and ak. Okay, what is that information? Xt is real and even, having a fundamental period of 6. Okay, so omega naught can be obtained. But dear, important point, if xt is real and even, okay, the Fourier series coefficient ak or ck, ak here, okay, ak are also real and even. If a signal real and even, Fourier series coefficients real and even. Okay, the good question, conceptual question, 2 marks, 2021 ECE. Average value. Now, what is the average value of a signal? Average value of a signal is also its DC value, that is A naught. Okay, that is A naught. The Fourier series coefficient, because if you take K0, then you get the DC value. Okay, so that is also A naught. Okay, and then AK are given as AK equal to K. Now, this is important. Okay, what is given? AK equal to K for 1 less than equal to K less than equal to 3. Okay, and 0 for K greater than 3. Okay, so what is AK actually? Now, what is AK? Now, see, K equal to 1, answer will be 1. K equal to 2, 2. K equal to 3, 3. So, 1 and 2 and 3. But But AK are also real and even, and at the same time A naught value is separately given. A naught value is 2. Okay, A naught value is 2. So this is K equal to 0. This is corresponding to K0. But whatever on the right will be on to the left because of even symmetry. This is the actual AK. They have given for K 1, 2, 3, but whatever is for K 1, 2, 3, same answer for K minus 1 to minus 3. 1 and 1, 2 and 2, 3 and 3. Even, mirror image. The value at origin, that is A naught, is given by the average value, that is 2. Now, what is the average power of the signal? Given the Fourier series coefficient, average power is given by the Parseval's formula. Parseval's power formula. The average power of the signal, which is actually for which is actually given by 1 upon t for periodic signal. Okay, 1 upon t integral over one time period modulus xt whole square dt is equal to summation of modulus ak whole square for k minus infinite to infinite. Okay, the summation of mod ak square. Okay, so answer is 3 square plus 2 square plus 1 square, then again 2 square, then 1 square, 2 square, and again 3 square. Okay, so this is 9 plus 4, 13 plus 1, 14. 14 will come twice of 14, same calculation left side, plus at the center 4, 32. 32. 32 is what is the correct answer actually. 32 is what is the correct answer. Average power, okay, using Fourier series coefficients is determined using the Parseval's power relation. Okay, dear. Okay, 32. Final answer, Sai Vikas and Sanmukha, will be 32. Okay. Good question, conceptual question. Okay, some basic points you have to link up. Okay. Yes, Chinmoy, correct. Next question. Let ft be a periodic signal with the fundamental period t naught greater than 0. Okay, consider the signal yt equal to f alpha t. Direct question. 2 marks ms cube. 2 marks ms cube. Direct property question. Okay, on time scaling. Yt equal to f of alpha t, alpha greater than 1. The Fourier series expansions of ft and yt are given to you. So ft has the Fourier series coefficient ck. Yt has the Fourier series coefficient dk. Okay, which of the following is or are true? Okay, now time scaling. Okay, time scaling, Fourier series coefficients are unaffected. Very important property. By time scaling, multiple time questions have come upon this. The Fourier series coefficients are unaffected. So for yt and ft, for both of them, Fourier series coefficients will be same. dk equal to ck. Okay, so one correct answer is A. Okay, it will not be modified. Okay, then period. Yt is equal to f of alpha t. What happens to the period if a signal, suppose, understand, this is also standard rule, but you can understand logically. Suppose if I tell you 2t, alpha greater than 1, 2t. So 2t means compression. If you compress a signal, time period also compresses, time period t by 2. Time period t by 2, t naught by alpha, d, t naught by alpha. D, A and D. Correct, Sumukha. This is correct. A and D are the two correct answer. Direct property question for 2 marks MSQ. Okay. Next one. Consider a discrete time periodic signal with period 5. Let the discrete time Fourier series. Now DTFS. The question on DTFS. GATE 2023 ECE 2 marks. Okay. So there is a discrete time periodic signal with period 5. Let the discrete time Fourier series representation be given to you. Summation k 0 to 4 ak e power jk 2 pi by 5n, where a0, a1, a2, a3, a4 are given. What is the value of this sum? Summation xn sine of 4 pi n by 5. Summation of xn. Okay. Yeah, for the previous one, Sai Vikas, Chinmay, correct answers, all of you, Sumukha. Okay. Now, this is the DTFS representation. Okay, where again ak becomes the Fourier series. Okay, also known as DTFS, discrete time Fourier series coefficients. Okay, dear. What is the formula for the discrete time Fourier series coefficients? AK is given by the formula in case of discrete time. It is given by the formula 1 upon n. Okay, 1 upon n, or I also remember it by the DFT formula. You can also relate it as 1 upon n xk, where xk is the DFT formula. Or if I have to write down the independent formula for this, it is given by 1 upon n. Okay, summation n equal to 0 to n minus 1, that is one period, x of n e raised to the power minus j 2 pi by n into kn. Correct. This is the formula for AK. This is the standard formula for Fourier series coefficients. Okay. Fourier series coefficients. Okay. Now, what is the value of this sum? Summation xn. Now see, summation xn into e power minus j theta term comes in the Fourier series coefficient formula. So can I not break the sign also as e power j theta and e power minus j theta? My problem looks like solved in that case. Correct. See, so I'll start here. The question is, okay, find the summation n equal to 0 to 4 xn sine of 4 pi by 5 into n. Now see here, summation 0 to 4. Why? Because our actual value of n is 5, right? Period n is 5. Okay, so summation automatically becomes 0 to 4. Okay, summation is going to become 0 to 4. Okay, then what comes inside? X of n e raised to the power minus j 2 pi by 5 into kn. This is what is going to come with n equal to 5. Okay, let me open the sign term. Okay, so the summation is summation 0 to 4 x of n multiplied by sine. Now what is the value of sine? Okay, e raised to the power j theta, e power j 4 pi by 5n minus e power minus j theta divided by 2j. Divided by 2j. Okay, number one thing, the 2j you please shift outside. Then what is left? Okay, then you have summation n equal to 0 to 4 xn e power j 4 pi. So I can write down 4 pi by 5 as 2 pi by 5 into 2n into 2n. Okay, then next minus summation n equal to 0 to 4 x of n multiplied by e power minus j. E power minus j, or let me write it e power. This also I will write it as minus j format only, because our coefficient formula has e power minus j, na? Okay, so I'll write down the first one as e power minus j. I want plus 4 pi, na? I'll write it as 2 pi by 5 into minus 2n. Now, okay, minus minus plus. This one I will write e power minus j 2 pi by 5 into 2n. Correct. This is how I will write these two. Okay, so then this is equal to 1 upon 2j. What is this formula? This is again the Fourier series coefficient formula corresponding to k minus 2. This is corresponding to k equal to 2. Okay, but if you only want the summation formula, okay, the m has to be shifted on the right side. Summation xn e power minus j 2 pi by n kn should be nak. Should be nak. What is n here? 5. Okay, so this part is 5 times which Fourier series coefficient? A minus 2 minus again 5 times a of 2. Okay, 5 I will shift outside, 5 by 2j. Now see, a minus 2, a2, what is given? a2 is given. A minus 2 is not given, a0, a1, a2, a3, a4. How will I calculate a minus 2? Okay. Okay, how will I suggest? How will I calculate a minus 2 now? Okay, DTFS coefficients. Okay, DTFS coefficients. Okay, are always periodic. Not the CTFS, but DTFS coefficients are always periodic, having the period of n. DTFS coefficients are periodic, having the period of n. Okay, so that is the point we can use here. Okay, so then my answer would be, okay, what is a minus 2? A minus 2 will become a3, because a minus 2 will be equal to a minus 2 plus 5. Okay, repeats after 5. Okay, so a3. And then minus a2 is anyways given to me. So now writing down the answer, 5 by 2j. What is a3 dear? Minus 2j, and a2 is 2j. Placing both the value, minus 2j, minus 2j. Okay, 2j cancel, 5 into minus 2, minus 10. 5 into minus 2, minus 10. Okay, answer A. Answer A. Okay dear, got it? Good question. Gate 23, EC 2 marks. Good question. Praveen, whatever gate notes you have, you revise and solve up to 1 mark question. That's it. Well means very easy questions will be there, mostly straightforward. So solve up to 1 mark question. Okay. Or little bit more practice means you can solve engineering services question. That's it. No need to go for separate sources. Okay, next question, gate 22, doubly 2 marks question on the DTFS only. Okay, the discrete time Fourier series representation of a signal xn with period n is given as summation k 0 to n minus 1 ak e power j k pi n e power I think this is 2 is typo error. Okay, how do we write the Fourier series? Now this has to be written as summation k equal to 0 to n minus 1, okay, 1 period, ak e raised to the power j k, okay, 2 pi, okay, so I think that is misprint, 2 pi by n into n, e power j k omega n, okay, omega also I think has come up here, both should not come up here, okay, summation k equal to 0 to n minus 1, ak e power j k omega naught n. Okay, so some typo error has been there. This is what is the Fourier series expression we anyways know. Okay, a discrete time periodic signal with period n equal to 3 has the non-zero Fourier series coefficients. Okay, so only two coefficients are non-zero. What are the two coefficients? A minus 3 equal to 2 and A4 equal to 1. Right. Now, since n equal to 3, again I am telling you, Fourier series coefficients are also periodic with period 3. Okay, so I need only 3 values. Okay, since the period is 3, I need 3 value A0, A1, A2. What is A0, A1, A2? Okay, so what is given? Is A0 given to me? A0 will be equal to A minus 3. Why? Repetition, period of 3. Okay, because period is 3, okay, AK is also AK plus N. Okay, so A0 or A minus 3 will be same, okay, which is equal to 2. Okay, then A1 will be same as A4 because they again have a 3 unit difference. Okay, that is equal to 1. A2, now A2, there is only 2 non-zero. Whatever the non-zero Fourier series coefficients they are given. So A2 not given means A2 has to be 0. Not given means 0 because they have clearly mentioned non-zero Fourier series coefficients. Okay, they have clearly mentioned the non-zero Fourier series coefficient. Okay, done. So now what is the signal? They are asking to write down the signal. So how do I write down the signal? That's what I've written there. Na? Okay, we write down the signal as summation n equal to 0 to n minus 1 ak e power jk 2 pi by n into n. Now substituting the data. Summation n equal to 0 to n minus 1, that becomes 2, sorry, k. Here also k. Summation k equal to 0 to 2 a of k e raised to the power j k 2 pi by 3 into n. Now let me open up. Okay, if I open, the first term will be a0, e power 0 will be 1. Okay, then next term will be a1 e power j, okay, k equal to 1, so 2 pi by 3n. Next term will be a2 e power j 4 pi by 3n. But what I just told you, what is the a2 value? A2 value is 0. Okay, so if A2 value is 0, what is the xn? Xn is going to be A0. A0 is A0 equal to 2 plus A1. A1 is how much? A1 is how much? Equal to A4, which is 1. Okay, A1 is 1. This was 2. Okay, so e power j 2 pi by 3n. This is the representation of the signal. But options are not given in this format. Options also have a cosine term. Okay, cosine is built up using e power j theta plus e power minus j theta. So what manipulation you might have to do here is 2 plus, okay, okay, 2 plus, rather than this 2, I need to bring this term. Na? Okay, what will I do? I will break this 2 as 1 plus 1 and 1 plus 1. And what about this 1? E power j 2 pi by 6n e power minus j 2 pi by 6n. Okay, this will become 1. And then I will break this as e raised to the power j twice of 2 pi by 6n. Can I write this way? Okay, can I write this way? Because inside cosine, cos 2 pi by 6 is coming. That is why I am writing it as 2 pi by 6. Okay, so twice of 2 pi by 6 will be 2 pi by 3. Now this is 1 plus, what is common? From both the terms, you can take e power j 2 pi by 6 and common from the last and second term. Then what is left here? E power minus j 2 pi by 6n. And here, one term outside, so 1 is inside, e power j 2 pi by 6n. This gives you cosine, e power j theta plus e power minus j theta, twice of cosine. So answer should be 1 plus twice of e power j 2 pi by 6n into the cos theta term with the theta 2 pi by 6n. Okay. 1 plus twice of e power j 2 pi by 6n, that is option number B actually. Twice of e power j 2 pi by 6n. Carefully you have marked the option, answer is B. Okay, Sai Vikas Chinmay, correct answer B. Okay, Sumukha, okay. Yeah, I'll plan. Okay. Anyways, for gate you can now remove FFT. FFT has been removed from the gate syllabus, that is okay. Okay. But up to DFT is important. DFT, DTFS, DTFT. Okay. Okay. Next question, dear. Okay. Gate 21EE. Simple question on Fourier transform. Consider a continuous time signal xt defined by xt equal to 0 for mod t greater than 1 and xt equal to 1 minus mod t for mod t less than 1. Let the Fourier transform of xt be defined as, okay, x omega equal to integral xt e power minus j omega t dt. What is the maximum magnitude of x omega? What is the maximum magnitude of x omega? What is the maximum magnitude of x omega? Now let us see. What is the xt given? Okay, xt equal to 1, xt equal to 0 for mod t greater than 1, but xt is 1 minus mod t. Now see, okay, xt is 1 minus mod t, that is given mod t less than equal to 1. If you have studied thoroughly, this is a triangle definition. How? Okay, no problem, I'll write it here. Now mod t less than 1. Mod t less than 1 means, okay, t can be 0 to 1 or 0 to minus 1. So t actually can be minus 1 to 1. That means, dear, okay, when the t is between minus 1 to 0, minus 1 to 0, if t is negative, what is mod t? Mod t is taken as minus t, so minus minus plus. And then if t is between 0 to 1, that is t positive, so mod t is t only. Mod t is t only. So this is xt, 1 plus t and 1 minus t. Okay, accordingly, if I wanted to draw this waveform, if I draw this xt waveform, for t 0 to 1, it is 1 minus t. Okay, minus mx plus c. Okay, the slope is minus 1. Okay, decreasing line. Y-intercept 1. It starts from here. Okay, this is y-intercept 1, negative line. 1 plus t, again y-intercept 1, but increasing line. Positive slope means increasing line from minus 1 to 0. That is what completes a triangle. I told you this is a triangle standard definition. 1 minus mod t by t, if the triangle is from minus t to t. Okay, so what is this signal? This is actually a tri-t signal. Okay, it's actually a tri-t signal. Okay, if it is tri-t by t, the definition is given by 1 minus mod t by t for your reference. Minus t less than equal to t less than equal to t. And such a triangle is a triangle from minus t to plus t having a total width of 2t, amplitude 1. This is tri-t by t. Okay, now the question, the very important formula, rectangle, triangle, is a very common Fourier transform pair. Okay, if it is tri of t by t, the Fourier transform is given by t sampling square omega t by 2. T sampling square omega t by 2. Adding for information, not required in this question, but rect t by t, Fourier transform t sampling omega t by 2. Sampling omega t by 2. You can also write in sinc function. I have written it in the sampling function format. Okay, I have written in the sampling function format. Now the given question, xt is equal to, okay, what is xt? Tri-t. It is from minus 1 to 1. Okay, so since the given xt is simply tri-t, means t equal to 1, what is its Fourier transform? Its Fourier transform will be capital T equal to 1. So 1 sampling square omega by 2. Okay, this is sampling square omega by 2. And the maximum value of sampling or sampling square, okay, this has a maximum at omega equal to 0 and the maximum value equal to 1 square, because the maximum value of sampling is 1. The maximum value of sampling theta is 1 and that is at origin. Okay, sine 0 by 0. Okay, sine 0 by 0 is 1. Okay, so maximum value of x omega, the maximum value of magnitude of x omega is turning out to be 1 unit. Okay, right. So you just have to identify the signal. Rest, if you have studied Fourier transform, even at basic level also, it's a basic Fourier transform formula question. Triangle Fourier transform. Try t by t, t sampling square omega t by 2. The given signal has to be understood as the triangle signal. That's it. Okay, that's it. Next question. Okay, gate 21 W2 mark. Okay, this is some property based. Okay, this is some property based. Let ft be an even function, that is f minus t equal to ft for all t. Let the Fourier transform of ft is defined as, okay, anyways we know the Fourier transform definition, integral ft e power minus j omega t dt. Suppose d by d omega of f omega is minus omega f omega for all omega, and capital F0 is 1. If you have studied Fourier transform, I'll solve this question independently, but if you have studied Fourier transform with derivations, you should know that such relation comes, okay, when you are deriving the Fourier transform of Gaussian signal. Such relation comes when you are deriving the Fourier transform of Gaussian signal. Okay, when you are deriving the Fourier transform of Gaussian signal. But anyways, okay, I'll solve it independently. I need to, what is given? Ft has some Fourier transform f omega. Now dear, some basic property. If ft has the Fourier transform f omega, on the left side derivative of f omega, frequency differentiation or t times property. Okay, tft has the Fourier transform j d by d omega of f omega. Okay, right side omega f omega comes in the time derivative. F dash t, okay, has the Fourier transform j omega f omega. Correct? J omega f omega. Now what is given to you? D by d omega of f omega. D by d omega of f omega is minus omega f omega. Correct? Okay. Now, if you convert to the time domain, derivative, okay, the d by d omega of f omega is the Fourier transform of which signal? J on the other side, you shift j on the other side, 1 by j tft, converting to the time domain. Right side also you convert to the time domain. So omega into f omega is the Fourier transform for divide by j here, 1 by j f dash t. Minus anyways is separately given. So this j part is cancelled. Okay, this j part is cancelled. Okay, you can write down t into ft is equal to minus f dash t. Or what is minus f dash t? Okay, what is the meaning of minus f dash t? Minus d by dt of ft. Okay, so we can rearrange this. Okay, dft upon ft, separating out the variable. Okay, equal to minus t dt. Okay, and then you integrate on both the sides. 1 upon f, integral df upon f, 1 upon f integral ln f. So log of ft equal to minus t integral t square by 2 plus some constant. So what is going to be ft? What function ft? Ft will be e raised to the power minus of t square by 2 plus c, or e power c I will separate out as another constant. I'll write it as k e raised to the power minus t square by 2. What is given? Capital F01. The question is, what is F0? Small f0, greater than 1, less than 1, equal to 0, equal to 1. Okay. What is going to be the F0? That I don't know because k is unknown. What is F0? F0 will become k, but how much is k? Okay. See, for that I'll help you. What is the given data? Listen to me. What is the given data is capital F0, and capital F0 is how much? 1. What is capital F0? The value of Fourier transform is at 0 frequency is the area under ft. So area under ft is 1. Now area under ft, this you can compare with the Gaussian function. Okay, and write down the area. Okay, if it is Gaussian function, if I want to write it in the Gaussian function format, okay, if I want to write it in the Gaussian function format, okay, see, e raised to the power minus e power minus of x minus mu whole square by 2 sigma square, 1 upon sigma root 2 pi. Okay, this has the area 1. Because the PDF, every PDF has area 1. Okay, so even if you take mu 0, okay, take the mu 0 and take sigma equal to 1, then you will have the standard Gaussian PDF. Okay, the standard Gaussian PDF 1 upon root 2 pi e power minus x square by 2. This has the area 1. So if I only want e power minus x square by 2, this will have how much of the area? This will have the area of root 2 pi. This will have the area of root 2 pi. Okay, this will have the area of root 2 pi. So area under ft, okay, area under ft will be how much? K into e power minus t square by 2. The area of e power minus t square by 2 will be root 2 pi. K into root 2 pi, this is 1. Okay, so the value of k is 1 upon root 2 pi. The value of k is 1 upon root 2 pi. Okay, so the value of f naught is k. Okay, k is 1 upon root 2 pi. That means less than 1. We have to compare na, less than 1, greater than 1, equal to 1. It is less than 1. Option number A. Option number A. Next question. Consider two continuous time signals xt and yt shown below. Okay, if xf denotes the Fourier transform of xt, then the Fourier transform of yt is how much? So first you have to relate the signals in time domain and then apply the Fourier transform properties. Okay, so as you can relate their Fourier transforms. So as you can relate their Fourier transforms, correct, no? Okay. Yeah, let's do it. So xt and yt. If xf denotes the Fourier transform of xt, then the Fourier transform of yt is how much? Then the Fourier transform of yt is how much? Yeah, let's do it. What is the relation between them? Now see, xt, if you see the xt, it has a width of how much? 1 unit, minus 1 to 0. This yt has the width of 4 units. Okay, that means expanded. Definitely expansion is there. Expand by 4. But if it was only expansion, dear, na? If it was only expansion, okay, if you expand by 4, it should go 0 to minus 4. 0 to minus 4, but it is minus 2 to 2. That means coordinates are also changed. So, and time shift is also there. How much time shift? How much time shift? How much time shift? So, see, if you see expansion by 4, that is clear, na? But how much time shifting? If you want to only know the value of time shifting, okay, what will you do? You will unexpand by 4. Unexpand by 4 means if this was compressed by 4. Okay, if uncompressed version has to be drawn, okay, so divide by 4, that will look like this, na? Minus 1 by 2 and then 2 by 4 is 1 by 2. Minus 1 by 2 to 1 by 2. Okay, now when you compare these two, okay, minus 1 to 0, minus half to half. That means, okay, this one, if you right shift by half, this goes to half. This minus 1 comes to minus half, correct? Okay, so this particular waveform, can be written as the given waveform xt right shifted by half x of t minus 2. Okay, so if you unexpand, sorry, not uncompress. Okay, if you unexpand means compress, but I'm just writing the reverse language so that you understand. So if it was not expanded, if you shift by half, okay, this is what? Now expand by 4. Okay. Now expand by 4. Okay, so when you expand by 4, minus half into 4, minus 2. Half into 4 plus 2, you get this one. And of course, amplitude reversal, plus 1, minus 1. That anyways I can write down. Okay, so what is the relation between xt and yt? Okay, y of t is number 1, x of t minus half, time shifting. But if you want to expand by 4 means t replaced by t by 4. Okay. So x of t by 4 minus half and then minus. Okay, this is minus 1, yt is plus 1. So amplitudes are, sign reversed. Okay, so I'll start from here again. What is yt? Is minus x of t by 4 minus half. Now, xt has the Fourier transform x omega or xf. I will convert to f domain at the end, no problem. X of t minus half, time shift property brings the phase term. Okay, exponential term, phase term, e power minus j omega by 2, same sign. Okay, then x of t by 4, x80 Fourier transform formula. If it is only x of at, the Fourier transform is given by 1 upon modulus a x of omega by a, right? 1 upon modulus a is 1 by 4, so 1 upon 1 by 4, x of omega by 4. But right now, this is the Fourier transform. Onto this, I am applying the scaling property. So every omega on the right has to become omega by a, has to become omega by a. Okay, e power minus j omega by 1 by 4 into this half I will write separate. Okay, so this totally actually becomes my 4 x of 4 omega e power minus j, okay, 2 omega. Right. So if I have to write down minus separately, minus x t by 4 minus half, the Fourier transform will be minus 4 x of 4 omega e power minus j 2 omega. In the f domain, it will become minus 4 x of 4f, okay, e power minus j 2 omega. Omega is 2 pi f. Omega is 2 pi f. Right. So, okay, so you will get it as e power minus j 4 pi f. Minus 4 x of 4f e power minus j 4 pi f. Answer A. Okay, gate 24, 2 marks question. Easy. Answer A. Na. Sai Vikas and Sumuka first told C. No, it is not C. It is A. It is A. In time domain expansion, so that you can directly say, dear. In time domain, I have clearly shown you first thing is expansion. Expansion in time is compression in frequency 100%. Okay, expansion in time, compression in frequency. Expand by 4, frequency compressed by 4. So definitely answer has to be x4f. This f by 4, you should straight away eliminate first of all. Okay, answer has to be in the 4f form. Okay, that you understand. Okay, compression in time. Okay, expansion in frequency. Okay, expansion in time, compression in frequency. Okay, because of this result. Okay, dear. Okay, next question. Okay, some good filter questions are expected from Fourier transform. Okay, but before that, 1 or 2 very easy questions of Z transform. I'll jump to that. Okay, very easy 1 or 2 questions only from Z transform we have seen here. Gate 21 doubly 2 marks. The causal signal with the Z transform Z square Z minus a power minus 2. Okay, is who's Z, the causal signal with the given Z transform. That means whose Z transform is this signal. That is what you have to identify. See, what is the Z transform is given as Z square upon Z minus a whole square. Power minus 2, I shift denominator. Okay, then you can write it this way. Suppose if it was AZ, standard formula, AZ upon Z minus a whole square, because the signal n a power n un. Okay, this has the Z transform. AZ upon Z minus a whole square. Okay, so denominator Z minus a whole square is giving me the motivation to write it in the form of AZ, but it is Z square, so 1Z outside, and there is no A in the numerator, so I divide A. So I can write this way, Z by A into AZ Z minus a whole square. Now what is Xn? See, 1 upon A is a constant. Now Z power 1 multiplied. When is Z power 1 multiplied? Okay, now see, if Fn has some Z transform Fz, okay, f of n plus 1, this will have the Z transform Z power 1 into Fz, na? Okay, or generally f of n plus n naught will have the Z transform of Z power n naught, Z power n naught into Fz. N minus n naught to Z power minus n naught will come. That is the property I am using, time shift property. Okay, so if it is, multiplied by Z, okay, multiplication by Z power 1 will come when you do Fn plus 1. So this has to be replaced, this signal has to be replaced as n plus 1. N plus 1, a power n plus 1, u of n plus 1. Okay, now 1a will get cancelled. So answer becomes n plus 1, a power n, and a power 1 cancel, a power n, u of n plus 1. Okay, n plus 1, a power n, u of n plus 1. Which is same as answer B. Why? Which is same as answer B only. Okay, this signal is also equal to n plus 1 a power n un. Why? Because you think this way. un plus 1 starts from minus 1. I'll explain this orally only, just listen carefully. N plus 1 starts from minus 1. Okay, but at n equal to minus 1, the signal eventually will become 0. Minus 1 plus 1, 0. So signal actually starts from origin only. Okay, signal actually starts from origin. So the value of the signal is 0 for n equal to minus 1. Okay, so actually starts at, so the signal actually starts at n equal to 0. So that is why un can be used. That's what, equivalent only. N plus 1 a power n un, option number B. Formula question. Got it? Okay, option B, Chinmay, not A. It is option number B. N plus 1 a power n un. Next question. Okay, if the Z transform of a finite discrete time signal xn is xz, then the Z transform of the signal yn equal to x2n is how much? Z transform of the signal yn equal to x2n is how much? Gate 24 EC 2 marks. Gate 24 EC 2 marks. How much it is? Now x2n, okay, x of 2n, z power half function will come. Okay, z power half, and that is given by answer C. This is a standard property. Okay, x of, okay, we usually write this way, x of root z. Okay, that is z power half plus x of minus root z. Okay, right. So x of an, because in time compression format, there is no generalized Z transform or DTFT property. Okay, if I tell you x of 3n, okay, so somehow there will be a term of the form, or I will write it like this, it will somehow depend on what? X of Z power 1 by 3. Okay, x of 4n will have a term of x Z power 1 by 4. There is no standard answer for time. There is no standard answer for time compression. Okay, time compression. Okay, so if it is x of an, a greater than 1, which represents compression, okay, will have no property, no standard result. Okay. Okay, but if it is x of n by a, okay, again assuming a greater than 1, which will be expansion if I write this way. Okay, so then property is defined as, just adding for information, if xn has the Z transform xz, if xn has the Z transform of xz, x of n by a will have the Z transform x of z power a, x of z power a. Okay, this is fixed, but here no standard result, but what can I say? It only depends on x of z raised to the power 1 by a, z raised to the power 1 by a. That is one thing you can note. There is no property for time compression in case of Z transform, in case of DTFT, in case of DFT, because time compression leads to loss of data. Okay, so there is no standard property in that case. Yes, Ivika, C is the correct answer for the previous one. Okay. Okay. Yeah, so I told you now only limited questions were there from Z transform, only these two. Okay, mostly direct only. Now coming back to Fourier transform, okay, application and filters question. This one is very easy. Gate 25 EE2 mark. This one is very easy. Okay. Ideal low pass filter has the frequency response given h of j omega or h omega equal to 1, mod omega less than equal to 200. Let ht be its time domain representation. What is the value of h0? If you know the ideal low pass filter, it's a direct question for you. Why? Because what is h omega given? If I wanted to draw it, h of omega equal to 1 for mod omega less than 200. Okay, that means omega, okay, less than 200 pi or up to minus 200 pi. H omega is 1. This is ideal low pass filter. Okay, so this ideal low pass filter passes up to which frequency? Up to 200 pi. This is omega c. This is the cutoff frequency. Okay, for ideal low pass filter, the impulse response, this is the frequency response, impulse response is written in the form of sine omega ct upon pi t. Sine omega ct upon pi t, or if you want to write it in sampling function format, it is also written as omega c by pi sampling omega ct. Sampling omega ct. Why? Why? See, because what is this h omega? This h omega is a rectangular function. Okay, this is the frequency response now. Okay, it is a rectangle function. Okay, rect of omega. What is the total width of the rectangle? 400. In the rectangle definition, we write down the total base as the denominator. Total base is 400 pi. Okay, then I told you some formula. Okay, I told you the formula, I'll repeat it. Okay, first I told you the time domain formula. Rect of t by t. Fourier transform t sampling omega t by 2. Okay. Duality says that if rectangle has the Fourier transform sampling, sampling has the Fourier transform of rect. So if I take the Fourier transform of sampling at, the answer turns out to be pi by a rect of omega by 2a. How it comes out? By duality property. By duality property. Sampling at has the Fourier transform pi by a rect omega by 2a. That is why if the answer is rect of omega by 400 pi, what should be the ht? Okay, so if you only have rect of omega by 2a, you can shift the a by pi on the other side. Na? You can shift the a by pi. How much is a? Okay, how much is a? This is generally equal to rect of omega by 2 omega c. Let's write down the standard formula. Okay, minus omega c to plus omega c. Ideal low pass filter, constant gain from minus omega c to plus omega c. Okay, so this is 2 omega c. So if you have 2 omega c, okay, what is the value of a? Is omega c. Shifting on the other side, you get omega c by pi. Okay, so that is what? Omega c by pi. Okay, sampling at, that is sampling omega ct. But then sampling theta is sine theta by theta, so it can be written in the sine form. Okay, so for ideal low pass filter, okay, the impulse response is simply given by sine omega ct by pi t, or omega c by pi sampling omega ct. This is the ideal low pass filter with gain 1. If it is gain, suppose k, so k will automatically be multiplied. Okay, with gain k, with gain 1 and cutoff frequency omega c. Okay, right. So you know what is the ht for our question? For our question, what is the ht? Is omega c. What is omega c for us? Omega c is 200 pi. 200 pi upon pi. Okay, sampling 200 pi t. Pi pi cancel. So it is 200 sampling 200 pi t. The question is, what is the value of h0? H0 is 200 sampling 0. Sampling 0, I told you earlier also, sampling 0 is 1. Sine theta by theta. Theta tending to 0, sine theta by theta is 1. So answer is 200. Sumuka correct answer. 200 is the answer for this NAT question. 200 is the answer for this NAT question. Okay, done? Okay. Yeah, you can solve it by area. I was just trying to add up the concept because next set of questions, okay, you need this formula. Correct, you can solve by area. Okay, what is there? I'll show it. For this question, okay. Okay, but I was just trying to make you recall all these formulas. Okay, what is H0? What is H0? Okay, 1 upon 2 pi times area under h omega. By the inverse Fourier transform formula, you can write this 1 upon 2 pi times area under h omega. Okay, so what is the area under h omega? Height into base. Height is 1, base is 400 pi. Right now, base is minus 200 to 200, 400 pi. Cancel by 2 pi, 200. Okay for this one, right? Okay, chalo. Right, but normally for the upcoming or for general also, for the type of questions, not only in this 5 years, but many questions for Fourier transform application will be around ideal low pass filter. Be ready for it. Let's have a look into the next question. Gate 22 EE2 marks question. This one is simple only again. Let the input xt is equal to sine, cos. 4 sinusoids are given, is passed through a system having the impulse response. Now please see, what is the impulse response? 2 sine 10 pi t by pi t, cos 40 pi t. If I separate out this much, sine 10 pi t by, if I separate out only this much, Sine 10 pi t upon pi t, sine omega ct upon pi t. So this is ideal low pass filter with the cutoff frequency 10 pi. This has to be ideal low pass filter having the cutoff frequency of 10 pi. But now multiplied by cosine, multiplied by cos 40 pi t. Okay, any signal multiplied by cosine, so modulation has to be applied. It is on modulation property. Okay, so what is the modulation property? I will put it this way. Okay, so if ft has some Fourier transform f omega, ft multiplied by cos omega naught t has the Fourier transform given by f omega minus omega naught plus f omega plus omega naught whole divided by 2. Okay, that means the spectrum is shifted to higher frequency. That is what modulating a signal means, shifting its spectrum to higher frequency components. F omega minus omega naught right shift, f omega plus omega naught left shift, whole divided by 2. Okay, so dear, if it is only sine omega ct by pi t, it is an ideal low pass filter. Okay, can I draw this ideal low pass filter? Yes. Okay, this much, minus 10 pi to plus 10 pi. How much gain? 1 gain. Okay. Leave this 2 also. I am only talking about sine 10 pi t by pi t. Then the gain is 1, cutoff frequency 10 pi. Okay. But if the impulse response is given to you, if the impulse response is given to you 2 sine 10 pi t upon pi t whole multiplied by cos of how much? The cosine frequency is 40 pi. Okay. So do we know the spectrum of this one? Okay. Yes. Okay, we already know the spectrum of this one. I will draw it again. This is the spectrum. Okay, which is centered at origin, 10 pi right minus 10 pi left, 1. Amplitude 1. So, this will have some Fourier transform h omega, frequency response, ht Fourier transform h omega, frequency response. What will be the h omega? Let me directly draw it, na? Let me directly draw it. Okay. What will happen? This particular spectrum, right shifted by omega naught and left shifted by omega naught. Amplitude divide by 2. No, don't divide amplitude by 2 because twice of cosine. I have taken 2 here. So amplitude 2 and 2 will nullify. So only this spectrum shifted by omega naught. What is omega naught? 40 pi. Okay, so first you have to shift this by 40 pi. Okay. Okay. 40 pi. Now right side 10, left side minus 10. Na? Okay, so 40 plus 10, this coordinate will be 50 pi and then the left side 30 pi. Okay, gain will not change as I told you. Left shift also, the left shifting, this will be minus 40 pi center. Okay, so this left side minus 50 pi minus 30 pi 1. Okay, this is the frequency response of the filter given. Okay, this is the frequency response of the filter given. Okay, now what is the output? Now sinusoids are given with different frequencies. What is the input given? Okay, 2 sine 10 pi t. What is the input given? xt. I'll just write down the input. 2 sine 10 pi t plus 5 cos 15 pi t. 5 cos 15 pi t plus 7 sin 42 pi t. And last one 4 cos 45 pi t. 4 cos 45 pi t. Okay. So now our filter is now not like a low pass filter. It is like it's a band pass filter. Now what you have got is okay, a band pass filter which will pass the band of frequency from 30 pi to 50 pi. Okay, any frequency outside the band will be rejected. Okay, so how much is this frequency? 10 pi, reject. How much is this frequency? 15 pi, reject. How much is the frequency? 42 pi, pass. How much is this frequency? 45 pi, pass. Any frequency from 30 to 50 will be passed. Okay, so output, and with how much gain? With gain 1. With gain 1. So the output of the filter, gain is also 1. Okay. Both of them are passed with how much gain? Gain 1. Okay, so that means whatever amplitude of input, Same will be there. The answer is 7 sine 42 pi t, 4 cos 45 pi t. Okay, it's a filtering question which actually becomes a band pass filter by the modulation property. Okay, so answer is this one, C. The 42 and 45. These two frequencies will appear in the output. That's it. Yes, Sumuka, correct. C is the correct answer. Okay. For these questions now, you have to be clear about the Fourier transform property. If you are clear with that, okay, you are in a good position to solve the question. Fourier transform properties and understanding of the calculations. Okay, dear. Next question. Next question. Let xt equal to 10 cos 10.5 Wt be passed through a LTI system having the impulse response pi sin Wt upon pi t whole square cos 10 Wt. Now this is not ideal low pass filter. It will be some low pass filter because sin omega ct by pi t square it is. Okay, square it is. Okay, so first I will alone treat this function. Suppose I take this function ft sin Wt upon pi t whole square. How can I write down this function? Or let me include the pi here. Only. Ft equal to pi into sin Wt upon pi t whole square. Okay. What I will do is let me take this pi outside. This will be pi square. Actually, this is pi square, and let me convert to the sampling form sin Wt upon Wt. So since W is not there, I am multiplying. Okay, inside the square, W square. So I have to multiply W outside also. Okay, so what is this function for me? Ft is W square upon pi. 1 pi got cancelled. Now sin theta by theta is sampling function. So this is sampling square Wt. And sampling square has the Fourier transform of triangle. Okay, what is the sampling square Fourier transform? Again, I'll repeat here. What is the sampling square Fourier transform? Okay, I'll write it here. Okay, see, I told you already triangle formula. Na? Triangle has the Fourier transform of sampling. Try t by t, the formula we discussed, t sampling square omega t by 2. Okay, by duality sampling square will have the Fourier transform of triangular function. Sampling square at, I usually write it in the sampling square at. This will have the answer pi by a tri omega by 2a. Pi by a tri omega by 2a. Okay, so what is going to be f omega? This w square by pi is constant. Now sampling square wt, place a equal to w. Okay, pi by w tri omega by 2w. Okay, pi cancel. The answer is 1 w tri omega by 2w. Okay, can you sketch this? Okay, I'll sketch this also. Now the impulse response, actual impulse response of the system is, okay, what is the actual impulse response of the system? Okay, the actual impulse response is this part pi sin Wt upon pi t whole square into cos, again cosine means modulation, cos 10 Wt. Okay, cos 10 Wt, right? Yeah, correct. This is like Ft. This part I told you Ft into cos 10 Wt. Okay, for Ft, what is the spectrum? I'm just drawing here separately. For Ft, what is the spectrum f omega? See here with me. What is the Ft spectrum f omega? It is a triangular omega by 2w having the height of w, amplitude w. Tri omega by 2w. So triangle I told you na, whatever is the denominator, okay, that will decide the coordinate. 2w, so minus 2w to w. Minus 2w up to the plus 2w. This is 2w, this is minus 2w, and height is w. This is f omega. But multiplying by cosine, okay, cosine will lead to modulation. Again, spectrum shifted to higher frequency. So what is h omega? I am now going to draw the h omega directly. In the previous question only I explained you the modulation. Now this ht Fourier transform h omega. Okay, this f omega once right shifted by how much? By the frequency of the cosine 10w. Okay, by the frequency of cosine. Okay, so this will come up here 10w. The triangle will now be centered at 10w. How much right, how much left? Right 2, left 2. Okay, so right 2W, left 8W. What is the amplitude here? W, but modulation will divide the amplitude by 2. So this amplitude W by 2. Okay, similarly to the left, minus 10W, okay, to this side, so this will be minus 8 and minus 12. Okay, this is the frequency response of the filter given to you. Okay, 2023 ECE 2 marks, good question. Previous one was EE. Now, what is the input? Okay, 10 cos 10.5t. Is it in the pass band? Again, it's like a, it's again like a band pass filter, not ideal one. Okay, the gain is not constant, but okay, it's band pass filter. What is the frequency of the signal given? 10.5 W. Okay, is it in the pass band? Yes, it's in the pass band. Okay, it's in the pass band. This is 10.5. Okay, I'll just remove it here once again. This is 10.5 W. And so you have to find the gain here. This is 10 W. Guys, quickly find this gain. Allow me a minute. How much is this gain? Okay, this is what I want to calculate. Okay, just allow me a minute. Okay, just a moment. Yeah, okay. Right. Yeah, so doing it now. What I told you, you have to find this gain here. How do you find the gain here? Okay, if it was ideal, then the gain is constant. It's not ideal, so we have to find this gain. Okay, so let's do it by the slope of this line. Okay, slope is height upon base. Okay, slope of the line can be calculated as height upon base na. Okay, so now see. Okay, how much is the total height if I calculate the slope from here? W by 2. And how much is this much of the base? Okay, 10W to 2W is 2W is equal to this gain. Okay, let us say this amplitude is A. Okay, so is equal to A. This height is A divided by how much is this base? Okay, this is the line I'm taking. Same line, same slope. This much line, same line. Okay, 10.5 to 12, 1.5 W. Okay, so solving this, A will be how much? By 4 here. So it is actually 1.5 by 4. 1.5 W by 4. This is the A here. Okay. So now dear, if the input is given to me, how much is the input given to me? Okay. Now see the input. 10 cos 10.5 T. 10 cos 10.5 WT. Okay. So input is again a sinusoid. Okay. Of the frequency 10.5 W. And this frequency 10.5 W is going to be passed. Okay, with how much gain? That's what I calculated, with the gain equal to 1.5 W by 4. So what is the output then? Multiply by the gain. Okay, multiply by the gain. There is no phase given anyways. Okay, multiply by the gain. So output is how much? 10 into 1.5 W by 4 cos of 10.5 WT. So it's going to be 15 by 4 W cos of 10.5 WT. Okay, answer is A. Answer is A. Okay, answer is A here. Okay, anyways, next question. Let's go to the next question. Okay, now this again, this, it's not that only gain is important, because the H omega is the real function. It does not have any phase. If it has phase also, okay, normally what is the, sinusoidal response you should know. If the input is, suppose A cos omega naught t, then output is given by how much? Generally output is given by A into modulus of H omega naught cos of omega naught t plus angle H omega naught. Okay, this is the general expression, the basic formula you must know, sinusoidal response. Okay, the amplitude of the sinusoid multiplied by the amplitude, the gain of the system at omega naught. Okay, at omega naught. Okay, the phase of the input signal is added with the phase of the system at omega naught, phase of frequency response. Okay, where h omega, okay, is known as the frequency response. Frequency response. Frequency response means Fourier transform of the impulse response ht. Okay, and then you break this frequency response into magnitude and phase. Mod h omega e power j angle h omega. Substitute the phase and magnitude at the omega naught. That is a general formula. As a quick revision, I have told you. Correct? As a quick revision, I have added this point. Right? This one is a good method, Samukha. That's what I'm telling. Otherwise, if you go, by convolution and other tools, it will be lengthy. Okay. This is the most suggested method to solve the questions. Okay, when sinusoids are applied. Okay, convert the system to the frequency response and then solve. Okay, even if some phase is given, that's what I'm telling you. This was a real frequency response. If the frequency response has some phase also, then also these are the standard formulas that you can use here. Okay. Yes, A correct answer. Yes, Chinmoy correct. We got A only, na? Yeah. A is what was the correct answer. Okay. Next one. This one. Then Z transform, I told you only 1 or 2 basic questions were there. Okay. DFT. DFT. Have a look into it. For a vector, okay, x bar, x0 to x7 be the 8 point, okay, DFT is denoted by capital X bar, okay, that is DFT of x bar, capital X0 to capital X7. 8 points are given, okay, where DFT formula, this is a formula that anyways we know that summation 0 to n minus 1 xn e power minus j 2 pi by n kn. Okay, the general formula, the general DFT formula is given as summation 0 to n minus 1 x of n e power minus j 2 pi by n e power minus j 2 pi by n into kn. Okay, where j is under root minus 1. Okay, if x bar is 1 000 2 000, this is the signal xn given. Okay, then another signal yn, this is x hat small means in the time domain. Another signal yn is DFT of x bar, DFT of xn. Then what is the value of y0? What is the value of y0? DFT of DFT. Okay, Fourier transform of Fourier transform leads you towards duality property. So this is on duality. Okay, this is on duality. See what they have told. This signal, this small x bar, this has the DFT capital X bar. Or let me write this way. Xn has the DFT xk. Let us come to the usual notation. Let us write this way. Okay, then duality. Okay, duality. Okay, so if you convert this k function into time function, okay, that is k equal to n. So it becomes a time function, and every time function will further have a transform. Okay, will further have a transform. Okay, what will be the transform? According to duality property, it is given by nx minus k. In this left side function, original time function, replace n by minus k. Nx minus k. Nx minus k. Okay. Right. So this is what? This is one DFT. Okay. You can call this as, this is the DFT of xn. Now again, DFT of DFT. This is the DFT of xn. Okay. So this is the next DFT. This is what? DFT of xn. Correct. Okay. So let this DFT of xn be y hat or be y bar. Okay. Be y bar. Okay. So what is this y bar? Okay, this is given to you as y bar, and that becomes nx minus k. Okay, the question is what is y0? What is y0? So simple, nx minus 0, or x minus 0 is x0 only, nx0, n is 8 here, length is given 8, it's a 8 point DFT going on x0. The value of the x0, the first value is 1. 8 into 1, answer is 8. A duality property question. It's a duality property question. Answer is 8. Answer is 8. Done? Okay. Next question. This was gate 22 EC 2 marks. Gate 24 EC 2 marks. Again on duality only. See, again this is on duality only. Okay, this is again on duality. The relationship between any n-length sequence xn and its corresponding n-point discrete Fourier transform xk is defined as xk equal to f of xn. That means xk is the DFT of xn. Okay, f of xn means DFT of xn, correct? Right? Another sequence yn is formed as below. Okay, yn is f of 4 times DFT. Okay, so DFT of DFT means duality, but multiple times duality property I'll have to apply. Okay, then for the sequence xn 1, 2, 1, 3, what is the value of capital Y0? Okay, now where capital Yk, if you again want to write capital like capital Xk, capital Yk will further be DFT of yn. Okay, of the small yn, where yn is xn. Okay, 4 times duality. Okay, in this capital Yk, what is y0 equal to? Okay, so let's apply the duality here peacefully. Okay, duality. Yeah, starting here. Xn has the DFT xk. This is the first DFT. Okay, I'll write here. This is the first DFT, correct? Okay, now applying the duality. Okay, what do we do duality? Replace k by n. Okay, this has the DFT capital N into x of minus k. In the time function, replace n by minus k. Okay, now this is the Fourier transform of the Fourier transform. Okay, so this is the second DFT. This is the second DFT. DFT of DFT. Once you apply duality, you get DFT of DFT. But I want 4 times. So this is already 2 times, 2 more times duality. But before I apply duality, let me make the representation simple. Suppose this is x1n time function. Usually we write by small letter. So x1n, okay, this has some DFT and suppose its DFT is capital X1k. I mean, I'm replacing this as capital X1k. Now again applying duality. Okay, now applying duality to this. It will be easier to understand the flow. So duality means convert the k function to n. Okay, I get capital X1n. Okay, this will have how much of DFT? Capital N. Convert the time function to k by replacing n as minus k. So capital N x1 of minus k. x1 of minus k. Done? Okay, now you have again written one DFT. So this is the third DFT. This is the third DFT. Okay, now again, before I apply one more time, let's say this capital X1n is some other signal x2n, small x2n, okay, and its DFT is x2k as always. That means this whole signal I am replacing as x2k. Now one last time duality. Duality, convert the k function to time, k equal to n. I get capital X2n. This will have the DFT. Okay. Capital N, okay, take this function and replace n by minus k. Okay, so x2 minus k. Okay, small x2 minus k. And this is the fourth DFT result. Okay, now this one is the fourth DFT result. This one is the fourth DFT result. Okay, now fourth DFT result, they are calling it as yn. Okay, this fourth DFT result, okay, they are calling it as yn. So what is yn? So what is yn? It is capital N x2. They have called it as function of time. Oh, no problem. I'll call it as, function of time only. Okay, let's call it as n x2 minus n. Okay, n x2 minus n. Okay, now I will start replacing the things. N. What is x2n? Come here. Come here. What is x2n? Is capital X1n. x2n is capital X1n. Okay, x2 minus n, capital X1 minus n, correct? Na? Minus n here, minus n here. So we got to capital X1 minus n. What is capital X1? See here, capital X1 k is nx minus k. Okay, so this will be n times small x. Keep looking here. This I am replacing here. N times small x minus k or minus n. Okay, k is minus k, so n will be replaced. Now already this is minus n. So if you replace minus n here, it should become minus minus plus n. Okay, it will be small x plus n actually. Small x plus n. Okay, so what is yn? Yn is actually n square xn. N square xn. Okay, now the question is y0, capital Y0, and capital Y0, whenever yk is the DFT of yn, the first ordinate property, capital Y0, okay, the first value of DFT, okay, for k0, the DC value is always obtained by, okay, summation yn, by summation of all values of signal. Okay, so this will be simply summation of yn. Okay, that will become how much? N square is a constant that you can place outside the summation. So n square summation xn. Now what is n? You see the length of the signal xn. Length is 4. Okay, so n square means 4 square, and summation of xn. Xn is given to you. Just add the value 1, 2, 1, 3. 1 plus 2 plus 1 plus 3. So this becomes 16 times, and this is 3, 4, 7. 16 into 7, 112. Correct answer. 4 times duality had to be applied to get to this answer. Okay, no problem. Learn. That's what. Learn the varieties. Okay. Learn the varieties. Okay. Okay. All right. Yes, guys. Okay. So 112. Final NAT type answer 112. Now, one thing I wanted to mention here. See, if you talk about the fundamentals like classification of signals and systems, you have seen the questions from there. Okay. So from the classification part, classification of signals or classification of system, those questions we have done. From the convolution, numericals as well as concept questions we have done. Then continuous time Fourier series questions done. DTFT, continuous time Fourier transform question done. Okay, continuous time, sorry, DTFS also done. DTFS also done. Okay, Laplace transform, there is no 2-mark question that I could see. Okay, Z transform question done. DFT question done. Okay, DTFT, okay, some 1 or 2 questions were there. And sampling theorem, sampling, some 2 or 3 questions were there. Okay, but I see a continuous dip in the attendance. Okay, now hardly few students are left. Okay, so like 1-mark question, I have completed all questions. This is what will be the leftover in this session. Okay, if you want, you can connect with me personally in the Telegram, because I think students are exhausted now. The attendance is clearly indicating to me. Okay, so this is the leftover, but yeah, these 2-3 questions from sampling have been really good questions. Okay, have been really good questions. I mean, even if I take these 2-3 questions, minimum half an hour will go only for discussion of sampling questions. Okay, but I suggest you to go through it, important question sampling. Okay, especially recent year. Okay, this year also, gate 25 also. Okay, shifted impulse train, what is the effect on sampling? Okay. All right, guys, so I'll stop for it, but majority is done. Just 1-2 questions for DTFT and this 2-3 questions from sampling. Okay, were left out. Okay, if you are preparing for gate 26 and you have not had any systematic preparation, but you want to still conquer the gate 26 in this lesser amount of time. Okay, so 2.5 months, or for ECE now you can approximately say 3 months left, because the gate exam is on 14-15 February. Okay, so the online crash course in the recorded format is available at Om Institute, which will give you a quick revision of all the key concepts. Okay, and the major target will be to enhance, to strengthen your problem solving capability, to think how a problem can be solved. The fee for this course is 8,500. It's a pre-recorded course. Okay, so that is available. On the app. Okay, you can scan it. Okay, and even if you think you have prepared through any regular course and want a quick revision, okay, so even for repeaters, this can help you as a quick revision course. Okay, so it is helpful for both. Okay, freshers as well as those who wanted to revise as a repeater. Okay, also guys, Full-fledged course anyways available. Okay, so if you're preparing for GATE 27, okay, you can opt for 2 years validity course for GATE 27, the fee 28,999 for 2 years validity. Okay, so yeah, that is also online live course available. For GATE 27, offline courses will also be available, but that will start from February after the commencement of the GATE examination. So for GATE 27, anyways, offline course will come. Okay, but online courses are already started, that you can opt for the 2-year validity. Okay, and also guys, if you have not prepared mathematics and if you are in Hyderabad or can come to Hyderabad for around 10 to 12 days, so engineering mathematics special offline course, okay, we are launching this 19th November. Okay, here, that is this Wednesday only, okay, day after tomorrow. Okay, offline classes, okay, in Hyderabad, okay, dedicated to engineering mathematics, because you know it has a pretty decent weightage, 13. Okay, so can you target to score 13 out of 13? Okay, yes, you can target. And also, not only weightage, of course, this weightage is higher than technical subjects also, but also if you are good in mathematics, you have the capability to understand, you know, most of the subjects easily. Okay, so you can attend the offline classes if you can be in Hyderabad. Okay, the fee for this course will be 5,000, or if you are any of the OM old student, you can attend it at 3,000 if you have taken any type of coaching from OM online or offline earlier. Okay, that's it guys. I'll share you the PDF. The previous PDF is also pending. I'm going busy with several sessions and work right now, but I'll share you the PDF. Don't worry. If I have told you, if I'm giving you the password also especially, I'll share you the PDF. Okay, so the password for today's PDF, okay, simply SS2. I think previous one, I don't remember, I kept, I think SS1. Okay, but whatever it is, the password for today's session, SS2, signal system 2. S and S in small, SS2. Okay, please note this password. Yeah, control systems also I will share, Ashrita. Okay, I told you now, I just going busy with several things, so I just forgot to share the PDF, but I'll share it with you. The password for this PDF, please note down, those who watch the video, they get this password, SS2, SS in small. Okay. All right, I'll share the PDFs in this group. Okay. I'll try to share all the PDFs together very soon only. Okay. This is the Telegram group. Okay guys, bye-bye. Thank you. Stay safe and take care of yourself.